All right, let's go ahead and dive in and get our first lab started here on live equipment. What I'm going to do first is show you pings on a Windows PC because I want you to see those and be able to compare them to a Cisco router ping because again the hosts that we're using here are actually Cisco routers, and I'm doing that because I want you to get used to pings on a Cisco router because that's what you're going to see on your exam. Let's go ahead and bring up Windows here, and you can see that I sent a couple of pings out, or actually just one, and I pinged my own website, resolved to the IP address. And you're not going to get exclamation points when you ping from a PC. You're going to get the reply from, hopefully, if there's nothing to come back from, or the ping is unsuccessful, what you're going to end up seeing is, request timed out, and then your troubleshooting continues. What I wanted to bring up to you here, a bit of a real world note for your studies. I know that sometimes when you see the output of some of these commands, and this is ping and all the different switches that we could use in Windows, and of course they're going to be much different on a Cisco router. But when you use iOS Help on a Cisco router to look at all these choices, as we're going to do throughout the course, iOS Help's a great learning tool, but you can't let it intimidate you. Because if we go over and run show and then put a question mark behind that, there are going to be like 75, 100, maybe even more options that we could use. There will be screens of options. And it's really easy to say, oh man, I'm never going to be able to learn all these. Well, that's the key. You don't have to learn all of them. We're going to go over the ones in this course and use the ones that you need to learn now, and you just build up from there. But very few people have the kind of job where they're going to be using all of these options all the time, plus all of the Windows options all the time. So don't think that you've got to memorize every single thing that you see on the screen. We're definitely going to go over the ones you need to know. Do not let these long lists intimidate you. So let's see. Let's go ahead and bring up the live equipment, and we'll head out to our rack. And right now we're on router 1, as you see R1 about 50 times there. And we're going to go ahead and ping all 3 of the other hosts from here. And it should work just fine, but I always like to trust and verify. There's nothing worse than starting a lab that you didn't test the pingability before you started, and then you end up troubleshooting something that you didn't really need to troubleshoot. So you've got your connectivity, and everything's up and running here, and that's perfectly fine. That's perfectly what we expect. Now we're on the switch, and I have all 4 hosts connected to one single Cisco switch. And the reason that there's no problem with communicating right now is that they're all in the same VLAN or virtual LAN. And you can see here the command show VLAN brief. Now I have students on occasion who will say something about this time, well, we don't even use VLANs. We just put the switch in. Well, if you put a Cisco switch in, you are using VLANs whether you realize it or not, because all of your ports are going to be in VLAN 1, all of your host devices, and it's even named default. This is the only VLAN that we're going to work with that will be named by default, and literally it is named default. So we've got a status of active, which is always good, and right over here it's going to list the ports that are in that particular VLAN. Now let me contrast this with show VLAN. And you can see show VLAN's giving you a lot more information here. It's giving you the same info at the top. Show VLAN brief. It's giving you the same info at the top. Then it's going into something called a SED, and then an MTU, and then some other values here, and remote span VLANs, and primary and secondary. That's not anything we're going to be working with yet. There is nothing wrong with using the show VLAN command. I just like to use show VLAN brief, because it gives you the information you need to get started with troubleshooting right away. This is going to tell you, here are your ports, here are your VLANs, here are the ones that are active, and if you were expecting to see, say, VLAN 22 here, and you didn't see it, then you know there's a problem right there to start with. So again, by default, all of our hosts are in the same VLAN. They're in VLAN 1, and this is called also the native VLAN. The default VLAN is the native VLAN. By default, it's VLAN 1. That can be changed, and that's going to come into play later in the course. It's a good thing to see now. So here are the pings that we sent around. They're also in the guide. And let's see. We saw the 5 exclamation points, exactly what we need to see. And you'll notice it says sending 5 100-byte ICMP echoes timeout is 2 seconds. That means 2 seconds between our pings, and that is the default. We're going to be using pings throughout the course, so don't worry if you didn't get all of that at one time. We're going to see them over and over and over again. So let's go down here. I've shown you the show VLAN brief. We've got the default. And again, here's the deal with the VLANs. VLANs handle broadcasts in this fashion, just like a regular LAN would, a physical LAN. When a host in a VLAN sends a broadcast, a copy of that broadcast is going to be sent out every port that is a member of that VLAN. Certainly sounds familiar by this point, right? But here's the good news. We can create multiple VLANs that will really help us limit the number of broadcasts forwarded throughout the network. Each VLAN is a separate broadcast domain at last. You know, we've seen collision domains get smaller and smaller as we've discussed them. You know, we started with the huge ones with our hubs and our repeaters, and then our bridges helped us segment the network, and we had smaller collision domains. Then we got to the switch level, and every single switch port is its own collision domain. So the collision domains kept getting smaller and smaller, and that's a good thing, but we weren't doing anything about the broadcast domains until now. So let's go ahead and bring up the equipment, and we're going to go ahead and create our first VLAN. And I'm going to put VLANs 2 and 4 in their own VLAN, and we'll just call that VLAN 24. Now, in a production network, of course, you're going to have standards. You're going to have change control procedures when you create a VLAN. Here's the numeric procedure, that kind of thing. And I understand that. That's great. You've got to have that at work. In your lab, though, anytime you create something, and even if you don't have a lab yet, that's fine. You're thinking, well, I'll never have one. You'll be surprised. But here's the key. When you're naming VLANs, when you're numbering VLANs, I should say, make the names intuitive. If you're putting hosts 2 and 4 into a VLAN, call it VLAN 24. It is amazing as your labs get more and more complex what a great organizational tool that is, because I can look at VLAN 24 later when I've got a huge lab going and I got 9 VLANs and I got a bunch of hosts and all kinds of things going on, and I can look at VLAN 24 and say I know what hosts are in that without even having to run any other commands. So let's go ahead and put interface fast 02 here, and okay, so we've got access VLAN does not exist, creating VLAN 24. Well, that is a really good thing, because most of the time in Cisco, if you're creating something that doesn't exist yet, if you're trying to work with a feature that hasn't been enabled yet, that kind of thing, you're going to get a message that says, hey, wait a minute, you haven't done such and such yet. Almost every single time. It's very helpful. In this case, it's even more helpful because it says access VLAN does not exist. I'm going to go ahead and create that for you. So that is a really good deal. So let's go down to 4. And it's the exact same command. I'll go ahead and type it out. Could use my up arrow to repeat that. And now let's take a look at show VLAN brief. And now look at this. We've got a VLAN 24. Note that it does have a name by default. I didn't type anything in. And it's going to say VLAN. It's going to give you 4 numbers. And obviously this is 0024. We can change these. That's handy for when, say, you've got an accounting department VLAN and a security department VLAN, that kind of thing. I'll show you how to do that shortly, but you can change the name. You're not stuck with this. Notice that the 2 ports that we just put in that VLAN, 2 and 4, they were in VLAN 1. Now they're over in VLAN 24, which is exactly what we wanted. So here's what we have now, and I apologize for the extra line here. No charge for that. Now, hosts 2 and 4 are in VLAN 24. Hosts 1 and 3 are still in VLAN 1, and we just verified that with show VLAN brief. Always verify it. I do say trust but verify to the point where, people make fun of it online. That's fine with me. I don't care. Just always check it. You will be glad you got in that habit as your labs get more complex, and so does your job. So this simple little configuration does a lot to limit the scope of our broadcast. Because before, when all 4 hosts were in the same VLAN, one host sent a broadcast, we know the rule. The switch is going to make sure every other host on the switch got it. But that comes at a cost. That comes as a cost of time and power. Now, when any member of either VLAN sends a broadcast, only the members of that particular VLAN are going to get it. So on a four-host device, four-host network, that's a pretty good deal. But imagine if this were a 64-host switch, and you've got half of your hosts in VLAN 1 and your other half in VLAN 24. You've cut your broadcast propagation in half, just like that, because every time, the load on the switch is cut in half. So that is a fantastic deal. Instead of sending out 63 copies of every broadcast, the switch would have to send out 31 sent by any host. And that is a huge load taken off our switch. It's a lot of broadcasts that PCs don't have to read unnecessarily. Just a great deal. Now, you've probably already gotten used to this, but in networking, it's like when we're talking about store and forward and cut through. There's always a trade-off. Yeah, this one's fast, but it doesn't have error detection. Well, this one is the slowest of the three, but it's got the best error detection. Well, something this good must have a problem, right? Well, there is a slight problem. If host 4 sends a broadcast right now, hosts 1 and 3 won't see it. That's a good thing. But what about other types of traffic, like, say, pings? What's going to happen there? And we'll go ahead and just do that right now. Let's go back out to 4. And let's see first off if it can ping the device that is in its own VLAN, which is device 2. No problem there. We did lose one ping at the beginning, which can happen as you're starting a lab, but then I just sent a second one and all 5 pings went through. So everything there is beautiful. Let's go ahead and send a ping to .1. And all I'm doing to go through the commands there, I'll go over this again later, but all I'm doing is using my up arrow to repeat a command that I just put in, and then I just overdo the 2 with a 1. Really does save a lot of time. Now, like I said, you might have one packet timeout at the beginning of a lab, but when you have 5 of them ping out, like timeout like we're seeing right now, or ping out, that's not good. So now 4 can't ping 1 where we had connectivity before. So what about 3? And see, this is a great thing about not getting cute with your numbering. In a lab, I gave router 1, I make sure that all the IP addresses end with the number 1. Router 2, all of them end with 2, and so forth. And now I don't have to think about, well, what did I put for 172.34.34.139? I just put 3, so I know I'm pinging router 3. And that's not going through. So right now, router 4 can only ping router 2, which is the other host in its particular VLAN. So did something go wrong with routers 1 and 3 all of a sudden? I think we know the answer to that question, but we're going to verify it anyway. Can 1 ping 3? No problem at all. Can 1 ping 2? There's a problem. And the reason that we have this problem, and we'll go ahead and ping 4 here, just to absolutely verify what's going on here. Yeah, they're not going through. So what you're seeing right now is that hosts in one VLAN can't ping another one. And you see the same thing on the board here. To analyze that, let me bring that down a little bit. There we go. And you can see the timeouts when host 4 is pinging someone router 2 in its own VLAN. There's no problem. But inter VLAN pings aren't going through. There's no inter VLAN traffic going through right now at all. Traffic can't go from one VLAN to another unless layer 3 gets involved, because then you've got to have routing involved. Now, obviously, that's likely going to be a router as far as your layer 3 device goes, but it doesn't have to be. There are 2 techniques to allow inter VLAN communication that you should be ready to configure and troubleshoot on the CCENT and CCNA exams, and you should be ready for these in the real world, because what we call layer 3 switches are very, very common out there today. They are switches that operate like a normal switch, but you can make some ports on that switch routing ports. And that may not mean a lot to you yet if you're new to networking, because we haven't gone over routing yet, but it is a miracle. And once you see it in action, you're really gonna love it. We also have a little something called router on a stick. And that's not a joke. That's actually what it's called. And you're going to see that live as well. Here's the thing, though. I don't want you to be introduced to those yet because you haven't gone over the fundamentals of routing yet in this course. Both of them involve routing. So I want you to go through the routing sections in this course before we tackle these. So for that reason, these two features are covered thoroughly in a separate section of the course. So again, we're going to come back to layer 3 switches and router on a stick. We're going to visit those after you've had some routing in this course, but I don't want you to see them in action yet. The one thing I want you to take away from this is that when we created multiple VLANs, that's when we start limiting the scope of our broadcasts. We know the deal there. A broadcast sent by one member of a VLAN is only going to be forwarded by the switch to other hosts in that same VLAN. The problem is we can't have inter VLAN communication without a layer 3 device layer 3 getting involved. And we will definitely see that after we've had some layer 3 work in this course. So let's go ahead and head up here. Yeah, we're going to talk about some networking models actually at the beginning of the next video. We got one more model to go, I promise. This is it. And it's only going to take us a few minutes, so it's a lot simpler than the other models were. This one does not map to the others. It's separate, and it only has to do with Cisco switching. So we will hit that and some more labs when we come back. I'll see you on the next video.